Welcome to Lesson 3 of Module 7, Infectious Disease. In this lesson, we're going to be focusing on the work of Koch and Pasteur. And by looking at their work, we're going to understand how they looked at and explain the causes and transmission of infectious diseases. So we have the germ theory, which in contrast was presented against the miasma theory. And the miasma theory that was that diseases were caused by the presence in the air of a miasma, which is a poisonous vapor in which they were suspended particles of decaying matter that was characterized by its foul smell. This theory was originated in the Middle Ages and endured for several centuries. That a killer disease like malaria is so named from the Italian malabad and aria air, and there is evidence of its suspected miasmatic origins. This was eventually disproved because by removing the causes of the bad smell, the reformers often moved the bacteria and the real cause of many disease. But then we had the germ theory, and this stated that many diseases are caused by the presence and actions of specific microorganisms within the body. And this theory was developed and gained gradual acceptance in Europe and the United States from the middle 1800s. Spontaneous generation is another term that will come up when we talk about Pasteur and Koch, and it's the hypothetical process by which living organisms develop from non-living matter. It's an archaic theory that utilized this process to explain the origin of life. And from the time of the ancient Romans through to the Middle Ages until the late 19th century, it was accepted that some life forms arose spontaneously from non-living matter. Such spontaneous generation appeared to occur primarily in decaying matter. And the pictures on our right show, in fact, some experiments that took place and then eventually disproved spontaneous generation, as there was no formation of maggots in meat that was in a cork-sealed container or a gauze-covered container, and therefore the one that was open was the only meat matter that formed maggots and therefore disproved spontaneous generation. Louis Pasteur was a scientist who provided evidence for the germ theory of disease, and he discovered that heating wine to about 55 degrees soon after it was made would kill most microbes responsible for spoiling the product, and therefore the wine could be left to age without turning sour. And this is the process we now know today as pasteurization. He also was responsible for the swan flask experiment, and this demonstrated that microbial germs are airborne and that life cannot be generated from a sterilized medium. And this is what we see on the right here. And he noticed that if the neck of a swan flask was broken, outside air can carry microorganisms into the broth. But as we see with the swan neck flask, as the broth cools down, the condenser collects water and it seals the mouth of the flask, and therefore no growth of bacteria occurs. Koch's postulate. So Koch established a relationship between microbial pathogens and disease, and he examined blood samples that were taken from patients that were infected. His main experiment was where he injected microbes into mice and found that they then developed similar diseases, and this helped to form a set of criteria to establish whether a disease is caused by a specific microorganism. So his 4 postulates are written to our rights. The first one, the microorganism should always be found in organisms suffering from the disease, but not in healthy organisms. 2, the microorganism must be cultivated in pure culture away from the body of the infected organism. 3, when this culture is inoculated into a susceptible organism, the organism should develop symptoms of the disease. And 4, the microorganism should then be re-isolated from the experimentally infected organism and recultured in the lab. It should be the same as the original microorganism. So this is how Koch found a link between particular organisms, microorganisms, and then particular diseases. And we can see here that in rats, this is exactly what they did. So we can see down the bottom here, when we isolate the pathogens, we can see that the same causative agent was the one that caused death in the diseased organism. That concludes lesson 3. Make sure you tune in for lesson 4.